What you just heard was the last alarm signal of the SKALA computer of Chernobyl Unit 4. And I rebuilt the sound generator that produced it based on the circuit diagram of the device, which is basically now entombed inside the sarcophagus. And based on what is known about the first minutes of the Chernobyl disaster, its timeline, it's very possible that this basically was the very last alarm before all systems went offline. Normally, this sound indicates any malfunction of SKALA, either hardware or software. But that April night, 40 years ago, things went very much different. The reactor explosion destroyed many connection lines between equipment of the unit and SKALA computer, so this alarm was triggered. Normally, when the alarm sounds, the chief computer operator has to flip this switch to turn it off, and then they can investigate what actually triggered it. But I doubt they had time, because after just 5, maybe 7 seconds, it just suddenly stopped. And then the ventilation that cooled the numerous computer racks also shut down, because systems simply lost power. And based on the interrupted printout of the operative teletype, it is known that the control room lost its power a bit earlier. And there passed quite a lot of time before it was actually restored. So that's why I say that it is highly possible that SKALA alarm was the last. And as more as I think about this, not from technical side, but from human side, just being this computer engineer in front of SKALA console and suddenly this happens, that had to be pretty much an experience. Well, so that's actually why I decided to make this separate video, so I think many of you would love to build the same device, so let's look how to do it. So physically, this alarm was not in the reactor control room, it was in the SKALA computer hall. It is here, inside this installation, which is a status display of the entire computer. In one of our recent videos we explained in detail how it actually works. If you didn't watch it, no problem, so to keep it short, here are 3 mnemonic panels. They glow with a beautiful turquoise color. So, this one shows operation and power supply of the elements of the reactor control room. The middle one indicates operation of 2 SKALA processors. And the rightmost shows operation and malfunctions of its main programs. I have to say, we are actually building a complete functional replica of it, and it will be ready next week, so get ready for a big and interesting video very soon. But there is more. In a couple of weeks, on the 25th and 26th of April, here in Kiev there will be a large Chernobyl exhibition. And there you will be able to see it, along with other devices we built, including the reactor control panel we talked about in one of the previous videos. So, the alarm sound generator is actually a very simple device. There are 2 oscillators. One is faster, it creates the rhythm. The other one is slower, it defines the tone. Then there is a driver and a simple amplifier connected to a speaker. There are also 2 potentiometers, one for adjusting the tone and another one for volume. There is a full list of components, so I did some shopping and managed to get almost everything in original period versions. I think you can easily find modern substitutes, but I believe you can also find original parts, say on eBay, for very little money. And so, what do we have here? These are MP26B transistors, which are used in the oscillators and the driver. Then, for the amplifier, there are these 2 very powerful P702 transistors. I have to say, if you look for substitutes, it's better to choose germanium rather than silicon. Next, we have these non-polar capacitors, and we will need just 2 of them. Then we have resistors, and almost all of them are original period parts, and as you can see, one package even has a military stamp. We also need 2 diodes. Well, I didn't have the exact type, so I used little bit more serious rectifier ones. Well, they will work perfectly. As for the electrolytic capacitors, well, I used modern ones because Soviets simply do not have such a long shelf life to be reliable. And finally, here is the highlight. That's a volume potentiometer. 68 ohms, still sealed, produced in February 1981. So let's open it. It looks just amazing. The speaker is also period correct, exactly as in the parts list, for GD35. But I believe you can use any speaker as long as it has the impedance of 8 ohms. So this is what it looks like when assembled, and now pay attention to a couple of really important details. So the circuit is designed to be powered with minus 24 volts DC. So there is minus 24 volts and 0 volts. You can use a standard power supply, you just need to flip the polarity. Then, when the signal wire is connected to the 0 volt line, it produces sound. And I warn you, it will be extremely loud. In reality, however, it works perfectly even from minus 4.5 volts. It just will not be as loud, but for your understanding, I have volume regulator at the very minimum. In this case, nothing here becomes hot, and you can assemble in the way I did. But if you use 24 volts, all these resistors must have the proper power rating. Some half a watt, some 1 watt, as in the list. And more importantly, these powerful transistors absolutely must be installed on heatsinks, because they become really hot. Well, it takes just 1 hour, maybe 2 hours to build all that, and you can have a unique piece of Chernobyl history right on your table. And I guess it's quite impressive, especially considering that the original device is there in darkness, and the holes of Unit 4 basically entombed behind the meters of concrete. So don't forget to subscribe so you don't miss our upcoming hardware creations. And in the meantime, you can find detailed updates and bonus content on our Patreon page. And we are very thankful to everyone who supports our work, because that helps bring the Chernobyl history back to life in the way it was never done before. And that said, stay tuned, thank you for watching, and we will see you in the next one.